Have you ever thought about how a swing works? Well, I know I have. It really all has something to do with angular momentum.
So what is angular momentum? If you look it up in the dictionary, it would describe angular momentum as the quantity of rotation of an object. But that's a lot of big words and doesn't really make any sense. So let's just think of angular momentum as its two concepts: moment of inertia and angular velocity.
Oh my gosh. You know, inertia is an object's tendency to resist change in motion. Moment of inertia, on the other hand, is an object's tendency to resist change in rotational or angular motion. Moment of inertia has two parts: mass and radius. There are actually different moments of inertia for different objects, but for right now, let's just keep it simple and stick with I equals mr squared.
Angular velocity, on the other hand, is just an object rotating about an axis in its speed. Angular velocity is usually represented by the lowercase letter omega, which basically means it's just a fancy letter W. Now that we've talked about its components, now we have to talk about the most important part of angular momentum, its conservation. And all that means is that if there's no external forces or torque acting on the system, then the final and initial should be equal to each other. Let's use Carlos as an example. As Carlos spins around, he has an initial angular momentum, with his angular velocity being as how fast he's spinning, and his moment of inertia being his mass and the radius, which is half his wingspan. But let's switch things up. Let's have him drop his arms. When Carlos drops his arms, his radius decreases. And since his mass stays the same, his moment of inertia will also decrease. However, momentum must be conserved. If his moment of inertia decreases, his angular velocity will compensate and will increase. The opposite would also be true if his radius increased. But since we can't make him taller, we can't show that. Now it's my turn to spin.
Let's try something else. Instead of changing the radius, let's change the mass. Karina will be holding two 2-liter soda bottles that she stole from Kenny. So we're still going to keep half her wingspan as the radius, but the mass is going to increase. So since the radius is remaining constant and the mass is increasing, the moment of inertia will also increase. But remember, momentum is conserved. Since moment of inertia is increasing, angular velocity actually has to decrease. And the same goes for the other way around. But we can't really show her mass just magically decreasing because we have a very low budget, so sorry. If you liked the video, don't forget to smash that like button, subscribe down below, and turn on that notification bell. Thanks guys, peace.